Hey explorers, have you ever dug a hole in your backyard or at the beach? You dig and dig, but how far down can you really go? What's actually under our feet? Deep, deep, deep inside the earth. Well, get your imaginary shovels ready, because today we're going on an epic journey to the center of the earth to uncover its deepest, most amazing mysteries. Imagine our earth is like a giant, delicious peach. The thin skin on the outside? That's the part we live on, called the crust. It's where we have our mountains, oceans, forests, and cities. But this crust is actually super thin compared to the rest of the earth. In some places, it's only a few miles thick under the oceans and a bit thicker under the big continents. It's like the crunchy outer layer of a candy bar. Now, what happens if we could magically drill past this crust? We'd enter the next layer, the mantle. This is the big, juicy part of our peach. The mantle is a huge, thick layer of rock, but it's not completely solid. It's super hot, so hot that some of the rock can slowly flow like super thick honey or toothpaste. Imagine that. This slow motion movement in the mantle is what causes continents to drift, earthquakes to shake, and volcanoes to erupt. It's like a giant, slow-cooking stew happening right beneath our feet. This movement pushes and pulls on the crust, creating all the incredible landscapes we see around us. Let's keep going deeper on our adventure. After we travel through the thousands of miles of the gooey, rocky mantle, we reach the Earth's core, and the core is split into two parts. First, we hit the outer core. This is where things get really wild. The outer core is made of super hot liquid metal, mostly iron and nickel. It's so hot that the metals have melted into a swirling, churning ocean of liquid metal. And all this swirling motion creates something incredible: Earth's magnetic field. Think of the magnetic field as a giant, invisible force field surrounding our planet. It protects us from nasty stuff from space, like harmful particles from the sun. It's also what makes our compasses point north. So without this swirling liquid metal deep inside the Earth, we wouldn't have this amazing protective shield. It's our planet's very own superpower, and it all starts in the outer core. Pretty cool, right? But we're not done yet. We have one more stop on our journey. At the very, very center of the Earth is the inner core. If we could get there, we'd find a giant solid ball, also made of iron and nickel. Now you might be thinking, wait a minute, if it's even hotter here than in the outer core, why is it solid and not liquid? That's a fantastic question. It's because the pressure at the center of the Earth is absolutely mind-boggling. Imagine the weight of the entire planet pressing down on that one spot. This immense pressure squeezes the metal atoms so tightly together that they can't move around and melt, even though it's unbelievably hot, hotter than the surface of the sun. So, we have a solid metal ball, surrounded by a swirling ocean of liquid metal, all wrapped up in a thick, gooey rock layer and topped with a thin, brittle crust. That's our planet. But how do scientists even know all this? We've never actually drilled to the center of the Earth. The deepest hole humans have ever made is only about 7.5 miles deep, which is just a tiny poke into the crust. Scientists are like detectives for the planet. They use clever clues to figure out what's inside. One of their main tools is studying the waves from earthquakes. When an earthquake happens, it sends out shock waves called seismic waves that travel all the way through the Earth. By measuring how these waves travel, how they speed up, slow down, or bend, scientists can figure out what kind of material they're passing through. It's like tapping on a watermelon to hear if it's ripe inside, but on a planetary scale. Another mystery is where all that heat inside the Earth comes from. Part of it is leftover heat from when our planet was first formed, billions of years ago. Imagine a giant ball of hot rock slowly cooling down over a very, very long time. But there's another heat source too. Deep within the Earth, there are special materials that are slowly decaying, a process which releases a steady stream of heat. This process, called radioactive decay, acts like a natural furnace, keeping the Earth's interior hot and active. This internal heat engine is the reason our planet is so dynamic and alive. It drives the movement in the mantle, which in turn shapes our world. Without it, the Earth might be a cold, dead rock, like the Moon or Mars. So we have this incredible engine to thank for the beautiful and ever-changing world we call home. Let's quickly recap our incredible journey. We started on the crust, the thin, rocky skin we live on. Then we plunged into the mantle, a thick layer of rock that flows like super slow honey. From there, we swam through the liquid metal outer core, the source of our planet's protective magnetic field. And finally, we reached our destination, the solid, super-pressurized inner core, a metal ball hotter than the surface of the sun. Isn't it amazing to think about what's happening miles and miles beneath your feet right now? The Earth isn't just a solid ball of dirt. It's a complex, dynamic, and fascinating planet with layers of mystery. The next time you see a mountain or feel a tiny tremor, you'll know it's all part of the incredible story happening deep inside our world. Thanks for joining me on this amazing expedition to the center of the Earth. I hope you had as much fun as I did. If you enjoyed our adventure and want to explore more awesome science mysteries, don't forget to hit that like button and subscribe to the channel so you won't miss our next journey. Keep asking questions and stay curious, explorers. See you next time.